Topic 2, multiply and divide rational expressions. The first objective within this topic is to do just that. We're going to multiply and divide rational expressions. And if you remember, rational expressions are just more complicated fractions. And so it's the same process as what you learned to do in elementary school when you were multiplying and dividing fractions. I've listed the steps I'm going to take to master this objective, so please follow along as I take this step by step. I'm not going to show my math of how I'm factoring, because that should be reviewed from topic 1 and even module 2, really, way back when, of factoring by taking the GCF or by the MATLAB T-chart, all right? So that you're just going to be, it's a lot of review from topic 1. The only new learning is what happens when it's a division problem. You have to multiply by the reciprocal. So you're still going to factor, you're going to state excluded values from the denominator, what the variable can't be, because you can't have 0 in the denominator. You're going to flip or multiply the reciprocal if it is division, and then you're going to cancel out like factors and write the simplified expression with the excluded values. All right, so it's a lot of review from topic 1. But to begin, I'm going to factor if necessary. Actually, before I do this, I do want to talk just briefly about if you were given a fraction of 1 over 4 and you are asked to divide 2/3 by it. This is the same process as rational expressions. What that means is you're going to multiply by the reciprocal. So 1 over 4 is now being multiplied by the reciprocal of 2 over 3, which becomes 3 over 2. So you flip it. It's the same thing. So eventually I'm going to flip this second rational expression because of this division sign. All right? So just keep that in mind as you're doing this. If it's multiplication, you don't have to do step 3. Just, you need to notice that. Those are some mistakes I see is you don't notice that it's division, so you forget to flip it. All right, factor if necessary. Step 1. I'm going to write factored form. I need to get this big rational expression or operation of division into factored form. All right. I see 4 pieces. The top left, the bottom left, the top right, the bottom right. The top left, bottom left, top right need to be factored. I know that to be true because they look like one big piece that can be broken up into smaller pieces. I know that 2 and 8 are even, 8 and 40 are even, and 8 and 32 are even, so I know all those can be broken down. All right? So I need to, if you remember, they're all 2-term polynomials, so I can use the GCF strategy, or finding the greatest common factor and factoring that out of there. All right? So I'm going to do the top left, 2m cubed plus 8m squared. The GCF between 2 and 8, biggest number that goes into both, is 2. Now the GCF of those variables, m cubed and m squared, is always the lowest powered variable that exists there. In this case, it's 2m squared. All right? And then I divide each term by the GCF. So 2m cubed divided by 2m squared. 2 divided by 2 is 1. M cubed divided by n, remember m's are bases, and so base divided by base, you subtract the powers. 3 minus 2 is just m. M to the 1, but I don't have to put to the 1. Remember, it's a 1 power. And then, moving on to the next term, I'm done with the first term. So the next term is positive, so I'm going to write plus. 8m squared divided by 2m squared, so divided by the GCF again. 8 divided by 2 is 4, and then m squared divided by m squared, it is the same as on the top as it is on the bottom, so they cancel out. I have factored the top left, all right? Let's move to the bottom left. Same thing, there's 2 terms, so I know I have to find the GCF. The GCF between 8 and 40, and this will be the biggest mistake that is made in this process, is you don't find the biggest number that goes into these 2 numbers, all right? So if ever you don't have factors eventually in this process that match up, then chances are you didn't do this process right, the one I'm about to show you. All right, so the greatest number that goes into 8 and 40. I agree 2 goes in there, but that's not the biggest number. I agree that 4 goes in there, but that's not the biggest number either. The biggest number that goes into 8 and 40 is 8, all right? If that doesn't jump out at you, then draw the factor tree and look for the biggest factor of each number. Now, I cannot include an m in my GCF because 40 does not have a variable. All right, so I'm done with the GCF. It's just 8. Then I do the first term divided by the GCF. So 8m divided by 8. 8 divided by 8 is 1. And then m divided by nothing is just m on top still. And then I move to the next term, negative 40 or minus 40, so now it's going to be a subtraction sign. So 40 divided by 8 or negative 40 divided by 8 is negative 5. Alright, so I have factored the bottom left. Now, moving on. Top right, same thing, two terms, got to find the GCF. In this case, the GCF between 8 and 32 is 8 again. And then, first term, and again, I don't include m in my GCF because this one didn't have an m. So 8m divided by 8. 8 divided by 8 is 1, and then I'm left with an m. 32 divided by 8 is 4, and it's plus because 32 is being added. So I am done factoring and adding my final piece. I didn't have to factor that 8, it was just a number down there. I'm done with step 1. Step 1 will take you the longest of this process, I promise, because there's going to be multiple pieces to factor. Step 2 says to state the excluded values. Again, this is review from topic 1. Excluded values exist. Let me write this out to label it. Excluded values exist in the denominator, and they are factors, all right? Because there will be numbers that the variable can't be, because that number would make that factor 0, and you cannot have 0 in the denominator. So the only factor I see, because again, this 8 is not a factor, and that 8 is not a factor, because they don't have variables, they're just numbers, they're fine. The only factor is m minus 5. So I know that m can't equal something. And the question I asked, I could set this factor equal to 0 and solve. You'd add 5 to both sides and m would equal 5. Or what number, if I put it in for that variable, would give me 0 in that factor? The only one that works is 5, because 5 minus 5 is 0. And since this factor is in the denominator, I have to say that m can't equal 5, because it would make it 0. And that's the only excluded value I have for this one. Sometimes there will be a lot more, just depending on how many factors exist in the denominator. Done with step 2. Step 3. Now step 3 only comes into play if it is indeed division, okay? This time it is division. And this is what we're going to do, the same thing as that process up there. We're going to multiply by the reciprocal. So I'm going to rewrite everything. Factored form style though. So 2m squared times m plus 4 over, I don't have to do anything with the left piece. It's the right piece that changes. Over 8 times m minus 5. Now, it was division. Now it's going to become multiplication. And I'm going to multiply by the reciprocal of this. 8m times m plus 4 over 8. The numerator becomes the denominator and vice versa. So 8 was on the bottom, now it's on top. 8 times m plus 4 was on top, now it's on the bottom. Multiplying by the reciprocal of that, meaning you just flip the two. So that is step 3. Done. Multiply by the reciprocal. If it's division. Now, there will be some where you don't have to do that if it's already multiplication. Like this one. You don't have to flip anything because it's already just a multiplication. Step 4, cancel out like factors, and step 5 is write the simplified expression. So, like factors that I see, I will do this one in a different color. There is an m plus 4 on top and an m plus 4 on the bottom. They go bye-bye. Now, there are 3 8s, but this 8 can cancel out with either one of those 8s in the denominator, it doesn't matter. But I can cross it out with that 8. So, step 4 then, to finalize it, to write what remains after that, I see a 2m squared still left on top over an 8 times m minus 5. Now, one final step that won't always be necessary, but sometimes it is, I have to simplify. This 2 and that 8 reduce. 2 over 8 reduces to 1 over 4. All right? So my final answer is m squared over 4 times m minus 5 because 2 8 reduces to 1/4. Please include the excluded value in your final answer so I can see that. Please include it in one nice and neat, orderly fashion. And I'm done. So go ahead and pause this video and try number 2 on your own. Factoring first, stating the excluded value, flipping because it is division if you notice, canceling out like factors, and then writing the simplified expression. Here is my work for problem number 2. I put it into factored form. Again, this time 3 pieces still need to be factored. The top right was 3 terms, so you needed to use the MACAB T-chart, okay? I got factors of x plus 10 times x plus 1. Step 2 was to state the excluded values, and that came from these 2 factors here. Again, 3 was not a factor, didn't have a variable, but 10x squared is a factor and x plus 1 is a factor. I got 0 from 10x squared because if I put 0 into that x, 0 squared is 0, 10 times 0 is 0. You can't have 0. And then if I put negative 1 into that x, negative 1 plus 1 is 0. You can't do that either. So my excluded values are 0 and negative 1. Then I did need to multiply by the reciprocal because it was division. So I flipped the second pieces. I flipped these 2. Alright? And then I canceled out like terms. This x plus 1 canceled out with that x plus 1. That 3 canceled out with that 3. So I'm left with x plus 1 times 10x squared. I flip them because of standard form. Highest power first. So 10x squared times x plus 1 is left on top. And then on the bottom, I only have an x plus 10 left over. Alright? So my final answer I wrote in simplified form. And my excluded values I included as well. And that is what you should have gotten. If you did not, please raise your hand and I will come check your work. Thank you so much for watching.